Hello, and welcome to this introduction of OpenText Core SAST Aviator. My name is Frans van Buul. I work in OpenText AppSec product management, and I'm going to be your host today. On a very high level, SAST Aviator is an AI-powered solution to remove SAST false positives and provide remediation assistance. Related to that, I have a couple of things on the agenda today. First, I want to provide a little bit more background on what this is beyond that simple phrase quoted above. So, how does this work? Why did we build this? How does this fit into our overall strategy and product portfolio? That will be quite short because we're going to spend the majority of our time looking at the product in action, demoing it. There are going to be two demo scenarios. First one is a demo scenario from the perspective of a developer or a security expert working locally with our products, typically in an IDE. And the second one is a demo scenario where we're doing everything in CI/CD, integrated in GitHub, where we're also going to see the automatic creation of pull requests with remediations for security findings. To understand the role of SAST Aviator, it's good to look at the main strategic drivers of the application security landscape today. We see three of them. The first is DevSecOps, integrating application security in the development processes so you can be at the same time fast, agile, and secure. That's not a new topic. We have been doing that for years, and most of our customers are doing that. But it doesn't mean that we're strategically done. We still need to improve that game, make things faster, reduce noise, make things easier for developers, make things easier to integrate. So it remains a key strategic focus for application security product management. Second one is complexity. We see that application portfolios have grown in size, have grown in variety of technologies. We see that software supply chains have grown a lot more complex. And the key goal is to reach effective risk reduction within that very complex application security landscape. Still a challenge in many cases. And then we have the introduction of AI, which is changing everything, influencing application security in many ways, introducing new security risks, introducing a new impact of application security testing as developers have starting to create more code automatically, but it also creates all kinds of opportunities to use AI within application security testing solutions. If you look at SAST Aviator, what it functionally does, it audits SAST findings, so determines, given a finding, whether it's a true positive or a false positive. Regardless of whether it is one or the other, it will provide an explanation why it has come to that conclusion. And in the true positive case, it will also provide remediation advice and, where possible, even automatic remediation. This has a really close fit with the strategic drivers we discussed, because the reason that we could create a system is the availability of AI. The problems it solves are new. Our ability to tackle them has increased exponentially thanks to the AI possibilities becoming available. And it allows us now to address some long-standing issues that are important for those DevSecOps and complexity drivers that we discussed as well. If you then look concretely what kind of benefits it offers for our customers, first of all, for those who have long security backlogs because they simply didn't succeed in auditing all the issues, this will finally give the opportunity to shred that backlog. You can dramatically accelerate auditing and remediation without spending more time and just get to a clean state again. For another group of customers, it's going to be really important that this will reduce developer friction. Developers aren't always happy with SAST. It's sometimes seen as a chore that has to happen because other people say it has to happen. But especially when those results contain massive numbers of false positives, or when the advice isn't actionable, or we still need to figure out many things yourself, that can sometimes be an unpleasant experience. With SAST Aviator, the results that developers will see will be much cleaner. The vast majority of false positives will be gone. And there will be a very concrete remediation advice that in many cases they can just accept. That is a much nicer experience. What we also know is that some customers filter out most of the SAST findings, only focusing on a few essential ones, because you just cannot do everything. You cannot do all that auditing. But still, there may be a real risk lurking in those issues that are currently being ignored. With this type of AI technology, you would actually be able to process these other categories as well and act upon them, which will improve your overall application security posture. So SAST Aviator, thanks to AI, can dramatically improve the overall effectiveness of your application security program. OpenText application security is available in 3 different deployment models. So we have an on-premise or off-cloud deployment model. We have a private cloud deployment model, which used to be called Fortify hosted. And then we have a public SaaS deployment model now called Core Application Security, which used to be called Fortify on Demand. The SAST Aviator functionality is available in each of those 3 scenarios. So we initially launched it back in 2024 for Fortify on Demand. In that case, the SAST Aviator functionality is completely integrated in the platform, and it's enabled by just checking a box on a scan. More recently, earlier in 2025, we also made it available for the other 2 deployment models. That specific service is called Core SAST Aviator. It's an add-on SaaS service even when you're in principle consuming Fortify as an on-premise piece of software. We've chosen to offer it like that because we need an extremely large LLM to make this work. And hosting that yourself is for most customers not a viable scenario. Fortify CLI, the existing open source tool that we created a while back to integrate Fortify components in all kinds of scenarios, is also declined for Core SAST Aviator. So that's what we're going to see during the demos. Our first demo will look at Core SAST Aviator from the developer perspective. I have a small demo application here in Java that contains some real vulnerabilities, but also phenomena that are known to trigger false positives when running it through SAST. I've already scanned this with OpenText SAST, and we can look at the results here in the IDE. In general, you can look at these results also via our web interface and or via a standalone tool called Audit Workbench. Today, I'm choosing to do everything in the IDE. You see there are 6 results. One very important one is a SQL injection. You're on line 47. It's true positive. It occurs because user input is used to construct a SQL statement by concatenation. And you would find in our recommendations that we recommend to change that into a prepared statement. By itself, that's a correct recommendation. But here we just give the example of how to do that in general. And it would still be up to the developer to implement that actual change and to think about what a change means in this specific situation. There are also some hard-coded password findings that are interesting to look at. Here, one on line 44 is actually a true positive. So it's the password secret PWD used to get access to the database. There's also one on line 22, and that's actually a false positive. So here we have a field initialized to the value, please provide a password. To a human, it's obvious that that's not a password. That is a message about a password that a developer has chosen to call password. But what a SaaS tool sees that operates via standard algorithms is that it's just a field called password that gets initialized to a string literal. And that is, structurally speaking, a hard-coded password. So that's why you get that finding. So you see, if you have regular SAST findings, there's still this task for the developer both to determine what is a true positive and what is a false positive. And for the true positives, they still have to think a lot about the remediation themselves and implement that. So those are the areas where we'll see that SAST Aviator can help. First, let's do the auditing part. We do that by invoking fcli. Making an error here like this. FCLI is our command line tool to glue all kinds of things in the OpenText application security portfolio together. We've chosen to also use this as a client for Aviator. We plan in the future to also integrate this more directly into our IDE plugins, so you can then just push a button, which will be slightly nicer. Also, in many cases, as we're going to see later, this will be integrated in the build pipeline, so developers wouldn't be doing that. But right now, if a developer wants to do this themselves, they need to do that from the command line. So it's done now. Results have been processed by an LLM. I can now refresh the results here. And what you're going to see is that instead of the original 6 results, I now have 4. So 2 of them have been completely suppressed. This is, I guess, what the developer would normally see. They wouldn't worry about the suppressed ones. But for instance, if you want to know what has been suppressed, or if as a security person you want to check what has been suppressed, you can, of course, still see them. They're not gone from the database. They're just labeled as suppressed. It's actually interesting to start by looking at one suppressed one here, the home controller 22 hard-coded password. We discussed that that's a false positive initially. Now, if we look here in the history of the issue, we see that Fortify Aviator, which was the old name of SAST Aviator, has changed the analysis from not set to not an issue, so suppressing the issue. And then here in the comments, you see that Aviator has actually created an explanation. So it says this is not a security risk. The string is not a hard-coded password, but rather an error message that is displayed to the user when they don't provide a password during login. And then it even provides some more context. This is a real accurate analysis, which exactly describes what to do here. The other one, of course, on line 44 is still a legitimate hard-coded password vulnerability, so it didn't get suppressed and it needs to be fixed. If we look at the SQL injection one, of course, that is also not suppressed. That's still there. In the comments, it would explain what's going on. It would also provide code as an alternative to what's there now. But importantly, this is not just random sample code. This is specific code that you could copy paste now into your IDE, and then it would work. That would still require you to do the copy paste. We wanted to go one step further and do true auto-remediation. So we've implemented that as well. And we can do that also from the command line. And again, at some point in the future, we'll integrate that more tightly into the IDE. The way it works now is that we need to specify the auto-remediations command, and I need to refer to the artifact ID that was just created, because the auto-remediation information is actually stored in that artifact ID. And now this goes very quickly, but it has done what we discussed. So you see here, we actually had a case here that we didn't discuss, but it was there where the user's password was being logged to standard out. So that's now removed and replaced by this message, do not log password. And we see that the statement created by concatenation has been replaced by prepared statement, which is exactly what needs to happen. So this is a very quick demo of Core SAST Aviator from the developer perspective. As a second demo, let's have a look at GitHub integration. In general, OpenText application security tooling is well integrated with GitHub and GitLab and other ones, because we know that many of our customers are doing that. We've done that for this application as well. We can see the workflows here in the standard GitHub workflow directory. You could have everything at once, and that's probably what you'll do in a production situation, but here I've separated them out just for easier demoing. We have a build one, which is not specific to OpenText at all. That's just setting up a JDK and running the Maven build of this project. We have the one to do the scan. That's the standard OpenText SaaS scan, which you execute here via Scan Central SAST, where the results will be automatically uploaded to our software security center. Then we have the audit one. The audit one also installs Fortify tools, and then it runs the Aviator SSC audit commands, where the application version is based on the variables that have been configured here. But essentially, that's the same command that you just saw. And then we have the remediate one. Remediate one also checks out the code. It sets up the Fortify tools again. and then it performs that command to apply the remediations. When applying remediations, you still need to determine like for which run of the Aviator auditing do you want to do that. So you essentially have some logic that says, well, just pick the last one. Going to probably add some functionality later in the product to make that easier to do, but right now it's pretty easy to script. And then interestingly, we make a pull request. So the auto-remediation will of course leave the code that's locally living in the GitHub runner and it changed the state at that point. So then we use another standard action to create a pull request. So let's have a look. I've already executed the first 3 steps here. So we can immediately start with the remediate one. Let's go there and run this one. And it's done. So now if we go back, we can see that a pull request has been created just now, containing remediation of the security issues detected by OpenText SAST. We see the commit being labeled, and we see the file change that has taken place where we eliminate the password logging and we replace the statement created by concatenation by a prepared statement. So that concludes our quick demonstration of how OpenText SAST Aviator can be integrated with GitHub. If you want more information about Core SAST Aviator, here are some useful links. We have a product homepage that contains a ton of information. There's also the technical product documentation that you can access, as well as the service description, which is more of a legal document describing this service. For now, thanks for watching. Bye-bye.